Hi guys, today we are introducing some characteristics of triangles and how to classify triangles. So we have two ways to classify triangles. That's according to their sides and their angles. And so when we talk about the sides, the classification according to sides, we have three categories. So equilateral triangle, isosceles, or scalene. And we say that an equilateral triangle is a triangle with three congruent sides. I'll just use some shorthand here, with three congruent sides. So that means that all three sides of the triangle have the same measurement. So if I were to draw a rough sketch here, all three of these are congruent. So we can usually denote that with just a little single tick mark there. On the other hand, in isosceles triangle, this is a triangle with two congruent sides. So we have two congruent sides instead of three. So the other one is kind of open to being changed. So we'll talk about this in future discussions, but these two sides that are congruent are referred to as the legs, whereas the other triangle, or I'm sorry, the other side is the base of the triangle. And then finally we have our scalene triangle, and this is a triangle with no congruent sides. So we'll say zero congruent sides. So notice that it's kind of a, it just really comes down to how many congruent sides are there as far as which camp a triangle would fall into. So for example, maybe something like this, where all of the sides have different measures. So we would classify this as scalene. Okay, then so that's kind of our scheme for classifying according to sides. We can also classify triangles, I don't know where my words are today, according to angles. And so if I talk about an equiangular triangle, this is a triangle with three congruent angles. So now instead of my three sides being the same measurement, my three angles will be that's not the best. My three angles will have the same measurement. So this actually is kind of an overlapping characteristic of equilateral triangles, is that the three sides are congruent and the three angles are congruent. So that would be an illustration of an equiangular triangle. Okay, we also have an acute triangle. This is a triangle with three acute angles. And so that means that all of the angles are less than 90 degrees. Right, so if I were to draw, actually equilateral triangle is a really good example, but all of these are clearly less than 90 degrees, so this would classify as an acute triangle. A right triangle, this is, obviously we can't have three right angles in a triangle. So that means this is a triangle with one right angle. And that's all that it takes to classify a triangle into this camp. So I have my right angle here, and then the other two angles will be acute. Okay, and then finally I have my obtuse triangle. This is a triangle with one obtuse angle, and the others by naturally will have to be acute, because if we have only 180 degrees to use and we use up a majority of them on this one angle here, then that means we classify the whole triangle as an obtuse triangle. Okay, so that's kind of our classification scheme. We also have parts of a triangle. So a vertex, if I'm looking at my diagram here, I have three vertices. That would be plural of vertex, A, B, and C. So that, we just say that a vertex is a point where sides meet. It's a point where sides meet in a triangle. A side would be, just as the name would imply, it's literally, connecting two vertices. So it's a line segment. Line segment that makes up a triangle. Makes up a triangle. Okay. We have an angle, which we know what angles are, but it's, a measure that's created with a vertex and two rays. So in a triangle, an angle is made of two sides and a vertex. And we want to make sure we're using proper notation. So this triangle here, we would write it using a little triangle. This is triangle ABC in our diagram here. Cool. Okay, so let's go through and actually classify some triangles by both angles and sides. So if I'm looking at this triangle here, notice that if I classify according to angles here, 62, 79, 39, those are all less than 90 degrees. So we would say that this is an acute triangle. Also, we don't have any indication that our sides are congruent, so that means they're all different. So that makes it an acute scalene triangle. Okay, next, if we look at number 2 here, we have 115 degrees for this guy here. And then we don't know what these other two angles are, but just the fact that there's one angle that is obtuse, it makes the whole triangle obtuse. And if I look at my markings, these are telling me that two of my sides are the same. We know that two congruent sides makes it an isosceles triangle. So it's an obtuse isosceles triangle. And then finally, this one, you'll start to see this pattern arise pretty frequently, but if I have three matching angles, they're all 60 degrees, that makes this, not only is it equiangular, because all of the angles are the same, angular, but it's also an equilateral triangle based on the fact that our markings are all single tick marks, right? So it tells us all of the sides are the same length. And just by the nature of all the angles being the same, the sides have to be the same, so it is equilateral. Okay, so we're going to see if we can draw some of these triangles. The first one is telling us to draw a right isosceles, so we know we have to fill in the blanks with there being a right angle. So we have our little right angle. And we know we want two of our sides to be the same. So these two are the same. Maybe make this one a bit longer. And then we have a right isosceles. An obtuse scalene, let's start by drawing our angle. So obtuse, remember, meaning greater than 90, so it's a really big angle here. Scalene meaning that all of the sides are different. So maybe I elongate this guy and take it back, right? So here I have different sized or different lengths for my sides, and my angle is obtuse. Acute equilateral. If I were to try and draw this, notice that there's a contradiction here because, well, no, not this one. So I'm getting ahead of myself here. Acute and equilateral, it's actually, this is just a redundant term because an equilateral triangle is by necessity going to be acute because all three angles have to be 60 degrees. So because all three are 60, then it's inherently an acute triangle. Versus an equilateral scalene, this is saying that I want all of the sides to be the same, but I want all three to be different. So this is a contradiction here. So if we just make a note that we have a contradiction, so it's not possible to draw this type of triangle. Not possible. Okay. Similarly, if I look at this one here, I'm trying to draw an acute, which means all my angles are less than 90, with an obtuse, which means that one of them is bigger than 90. So you can't simultaneously meet both of those criteria. So we would say that this is also a contradiction. So this is not possible. Not possible. Cool. All right, now we're going to kind of break down a diagram here and do some classifying. So in my diagram, I'm first checking out triangle ABD. Okay, and so I should notice that I have all three angles being 60 degrees, so I already know that this is equilateral. Okay, also equiangular, but equilateral kind of speaks for both of those criteria. Next, let's look at triangle BDC. So BDC. And here, if I'm checking out my angles, notice I have a 120, so it's already obtuse. And we have these single markings that match up. So two sides are the same, so it makes it an isosceles triangle. Okay. And then finally we have ABC. So A, B, C. And here I'm seeing that I have 1630 would make it 90. So this is already a right triangle. And we don't have any matching measures. All of my sides are going to be different. So this makes it a scalene triangle. So that wraps up some of the classification. So now let's use our understanding of classification to find some unknowns. Okay, so if I'm looking at this diagram here, number 8, and I see that I have all these single tick marks, that's telling me that all of these sides have to be the same measurement. And so I can actually just, and I'm looking for W, right? Well, W in this case. Okay, so I'm going to go ahead and set 2 of them equal. 5W equals 6W minus 5. And if I solve, let's add 5 to both sides. So 5W plus 5 equals 6W. Subtract 5W from both sides to get 5 equals 1W. So W just equals 5. And then if I substitute this back in, 3 times 5 plus 10 is 25. So that's the side of this guy here. 6 times 5 minus 5 is 30 minus 5, which is 25. And then over here, 5 times 5 is 25, right? So we're just confirming that it is, in fact, an equilateral triangle. Okay, over here, I'm noticing that, well, I have the double hashes. So those 2 sides are congruent, meaning I would set those expressions equal. 3x minus 4 equals 2x plus 7. So I could add 4 to both sides, giving me 3x equals 2x plus 11. Subtract 2x from both sides to get x equals 11. And then finding my expressions here, 3 times 11 minus 4 is 29. And then over here, 2 times 11 plus 7 is also 29. So how we can use our understanding of angle and triangle classifications